1.3. You are asked to study the causal effect of hours spent on employee training, measured in hours per worker per week in a manufacturing plant on the productivity of its workers. Output per worker per hour. Describe A, B, C, and D. A. Describe an ideal randomized controlled experiment to measure this causal effect. Answer 1.3a. You will need to specify the treatment or treatments and randomization method, as in questions 1.1 and 1.2. 1.3b. Describe an observational cross-sectional data set with which you could study this effect. Answer. One such cross-sectional data set would consist of a number of different firms with the observations collected at the same point in time. For example, the data set might contain data on training levels and average labor productivity for 100 different firms during 2018. Chapter 4 introduces linear regression as a way to estimate causal effects using cross-sectional data. 1.3c. Describe an observational time series dataset for studying this effect. Answer. The time series data would consist of observations for a single firm collected at different points in time. For example, the dataset might contain data on training levels and average labor productivity for the firm for each year between 1980 and 2018. Chapter 15 discusses how linear regression can be used to estimate causal effects using time series data. 1.3d. Describe an observational panel data set for studying this effect. The panel data would consist of observations from different firms, each observed at different points in time. For example, the data might consist of training levels and average labor productivity for 100 different firms, with data on each firm in 1995, 2005, and 2015. Chapter 10 discusses how linear regression can be used to estimate causal effects using panel data. Chapter 2 Summary. The probabilities with which a random